Hey everybody, this is your 5.4 notes video on the fundamental theorem of calculus. So to start with, we're going to be talking about the mean value theorem, and here's the formula. You have to have f continuous on a closed interval, and then what that means is some point c within that interval would look like 1 over b minus a, so basically 1 over the right minus the left, times the integral from the lower to the upper of the function. And then there's going to be two parts to the fundamental theorem. The first part has this formula. Again, if it's continuous, then f is the integral from a to x of f of t dt that's continuous. Then its derivative, f prime, would be the derivative of the integral from a to x of f of t dt, which is just f of x. In other words, what that means is if it's continuous, then if you do the derivative of the integral, then you get the original function. So just saying it's circular, it goes back to the beginning. And then part two is if f is continuous and f is any antiderivative, then the integral is the antiderivative, and it's using f of b, which is the right endpoint or the top, minus the other endpoint. We also have a net change, which was basically that same part, but that's equal to the integral from a to b of f prime. So the net change is in a differential function is the integral of its rate of change. Remember when we're doing f of b minus f of a, that's like the rate of change. Then, we're still going to be talking about area. In particular, area close to the x-axis, which is either above or below. So those are the main topics. So the summary is to find the area between the graph and the x-axis, subdivide it at the zeros or the x-intercepts, integrate it, which means do the integral, and add the absolute values, because you have to have a positive area, not a negative area. Okay, so that's the idea behind it. Like this picture is pretty good. It showed a positive area for this one and negative for this one. So you had to do the absolute value and then add them together. Okay, so that's the summary. So now let's get started with 5.4. So doing problem 1. We're doing problems 1 to 49, every other odd. So with problem 1, we're doing the integral from 0 to 2 of x minus 3 dx. So to start with, we need to remember that, okay, this is just going to be a side. If you have f of x equal to x, then the integral of x dx would be raise the power to 2, and then it's 1 over that power. Okay, so that's your first formula, and that's for linear. And if you do the integral for x squared dx, you raise the power to 3, and then it's 1/3. And then there could also be some particular constant out there too, because when you take the derivative of a constant, then it goes away because it's just 0. So that's how that works. We're also going to be doing like the derivative of like x squared, for example. Well, the derivative of that would be 2x. So just remember, when you're doing the derivative, you go down a level. When you're doing the integral, you go up a level, and you have to do 1 over the number and then plus c. Okay, so the first thing we're going to do on this one is distribute that. So we go the integral 0 to 2 of x squared minus 3x dx. And what we do is do your integral of x squared. And so the integral of x squared would turn into x cubed. And then we do 1 over that. So 1/3 x cubed. Then minus, okay, let's just put our 3 there, and then the integral for x would be 1/2 x squared. Okay, and this is to be evaluated from 0 to 2. To be evaluated from 0 to 2. Now, in this context, we don't use the plus c, but on indefinite integrals we do. Indefinite integrals are ones without boundaries. Okay, so let's plug in the 2 to both spots for x, and then you might notice already, if you plug in 0 to both spots, you're just going to end up with a minus 0. Okay, so 1/3 times 2 cubed minus 3/2 times 2 squared. Okay, well this, we could just do this on the calculator. Two to the 3rd power divide by 3 minus 2 squared is 4 times 3/2. Okay, that gives you negative 10/3. Minus 0, so it's just negative 10/3. So that's your answer. Okay, our next one is number 5. Okay, on number 5, the problem says do the integral from 1 to 4 of 3x squared minus x cubed over 4 dx. So when we bump this up a level, x squared turns into x cubed. We have a 3 in front, and since we bumped it up, remember we have to do 1/3 of that. So 3 times 1/3 x cubed minus, think of this as 1/4 in front from the fraction. Then bump the x cubed up, which is x to the 4th, and since we went x to the 4th, we need another 1/4 there. So that has got to be evaluated from 1 to 4. So your 3 times 1/3 cancels, so you have x cubed minus, this is 1/16 x to the 4th. And we have to evaluate that from 1 to 4. Okay, so let's plug in the 4. So we've got 4 cubed minus 1/16 times 4 to the 4th minus, okay, now we're doing 1 for both of these. We ought to start a parentheses so we don't make a sign mistake. And then 1 cubed is 1 minus 1/16. Okay, so let's evaluate that. 4 to the third minus 1/16 times 4 to the fourth. Okay, this part is 48, and this part is 15/16. And so when we do this, we get 753 over 16. So that's just 48 minus 15/16, and it tells you. So 753 over 16. Our next one is number 9. And on this one, we're doing the integral from 0 to pi thirds, which is like 60 degrees, but it's in radians. And we have 2 secant squared x dx. Okay, now this one is a little bit tricky if you don't remember your tangent derivatives. So this is a side. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. All these are x. And so on. So those are the basic ones. But you notice right there, the derivative of tangent was secant squared, which means the integral of secant squared is tangent. So that's how it goes back and forth. So what we're going to do on this one is bring our 2 in front, and we're going to evaluate this from 0 to pi thirds. And again, the integral of secant squared is tangent. So we put tan x right there. So then we just plug it in. So we have 2 tan pi thirds minus 2 tan 0. Or if you'd have preferred to do this, you could have said 2 times tan of pi thirds minus tan of 0. So let's evaluate those. So the derivative of tangent of pi thirds. Well, let's remember our unit circle for pi thirds would look like square root of 3 over 2 comma a half. That's from your unit circle. So here's pi thirds, and we have 1/2 comma square root of 3 over 2. So remember what we said a long time ago was it's xy, which is cosine sine, and tangent would be the y over x. So we take this one, divide by that one. So this would be 1/2 divide by square root of 3 over 2. Now your 2's cancel, and so you don't really have to do that part. It's just 1 over square root of 3 for that. So tangent of 0, well 0 has the ordered pair 1, 0, and so the tangent would be 0. And honestly, what I just noticed is I messed up. This should be tan of pi 6 was this. So tan of pi thirds would look like 1/2 comma square root of 3 over 2, and so your tan of pi thirds would be square root of 3 over 1, which is just square root of 3. Okay, so this is going to be 2 times, well, tan of pi thirds is square root of 3, and then minus 0. So this just gives you 2 square root of 3 for your answer. Okay. Our next one is 13. On 13, we're doing the integral from pi halves to 0, 1 plus cosine 2t over 2 dt. So if it was x, then you put dx. So if they're going from pi halves to 0, what that would mean is they're going this way, which is the clockwise position. So it's like clockwise. Because here's your pi halves, here's your 0, and you're going that way. Okay, so let's evaluate this. So our first step is going to be to divide this out. So this would be 1/2 plus cosine 2t over 2. So now when we do the integral of just a number, it's that same number with the variable after it. In this case, that'd be t. So we have 1/2 t. We have some more work to do, but we will have this go from pi halves to 0 like that. Now, this is the part that could be a little tricky. So earlier I said if you're doing the derivative of cosine, no, if you're doing the integral of cosine, you'd have to think, well, the derivative of what was cosine? The derivative of sine is cosine. So let's see, we need a 1/2, and then we change cosine to be sine, keep the 2t, and then we're going to multiply by 1/2 again. So let's work through that a little slow. Let's start with if we have sine of 2t, and we're taking the derivative of that. The derivative of sine 2t would be cosine 2t times 2, which we put in front. So this is just to the side. Now, we have a 1/2 here, and so you just got to figure out how these things work. If you're having a 1/2 in front, then we're going to need a 1/4 over here. So we're going to multiply this like this. You might need to do a little guess and check to compare it. So let's try that. If we do the derivative of 1/4 sine 2t, let's see what we get. So you'd have your 1/4, and then the derivative of sine would be cosine, and then you have an extra multiplied by 2 to the front. So this would be 1/2 cosine of 2t. And that's actually what we wanted. So that's why you're going to need to do the 1/2 times 1/2. So that's why it's a half times a half, or 1/4. So we have a half t plus 1/4 sine 2t. Now the evaluating part is like the easy part. So you're basically going to have 0 for the front, plus 1/4 sine. 2 times 0 is just 0. And then let's go ahead and do that part. Sine of 0 happens, well, 0 is right there, and it's at the ordered pair 1, 0. And so the sine of 0 would be 0. So we just have 0 plus 0. So all of that just goes away a little bit. So it's the next part that we're interested in. So like on that other one, we're going to do a minus and then a big parentheses so we don't have a sign mistake. And we're going to say 1/2 times pi halves plus 1/4 sine 2 times pi halves, and then close our parentheses. Okay, so actually that 2 over 2 cancels, and so we were going to have minus pi fourths plus 1/4 sine pi. So this is negative pi fourths. Okay, if we're doing sine of pi, pi happens over here at negative 1, 0. Because remember, it goes 0, pi halves, pi, 3 pi halves, 2 pi. Well, pi is over here, and the sine of pi would be 0. So this would be plus 0, and so all you do is get negative pi fourths. Okay, so that's number 13. Negative pi fourths. I decided before I move on, I want to remind y'all that you can do add graph, and we want 1 plus cosine 2x, all of that divided by 2. So there's the graph of it, and we want to do the integral. So menu, analyze, integral, and the lower bound you put pi halves, and then the upper you put 0. And so that gives me 0.875. Let's see, let me move my mouse pointer because I think it's negative. Yeah, there's sure enough it is. Okay, so there's my negative 0.785. Now, if you want to check your answer, negative pi fourths is negative 0.785. But in this problem, it wants it in terms of pi. There is one other thing I wanted to mention before I get too much further in this assignment, and that is if we go back to the other assignment, the very last problem, what I noticed is on the one we did in the book, our integral was just 0 to 1, and so I showed you all how to do that. But this problem mentions average value or average integral. Okay, I looked that up. So what it wants is average value, and since this is just 0 to 1, there's really nothing special I had to do, and so it wouldn't be obvious as to what the problem was if you were doing a similar one like that. But on this one, if you use the calculator to get your integral, you would get -88 and wonder, well, what did I do wrong? Really nothing. So if your integral was 0 to 4, you just divide that by 4 and you get -22. So let me just back up a little bit. Okay, so the problem was -3x squared minus 6, and so you're basically going to graph that -3x squared minus 6. Okay, so there's the graph. I'm going to do menu 4A to make it visible. So there it is. And I want to do analyze graph and do the integral from 0 to 4. So on lower bound I press 0, enter, and on upper I press 4. Well, that's why this little -88 shows up, and so you think that would be the correct answer. But since it wants the average value, then you have to take that -88 and divide it by the difference in these, which is 4 minus 0. And so that's why you get -22 for an answer. So that's just a addition to the video that I wanted to do. Okay, now we're doing 17 next. And on 17, the problem is the integral from 0 to pi 8. By the way, can anyone guess what pi 8 is? Well, pi 4 was 45 degrees, and so pi 8 can be thought of as, 22.5? Yeah, so think of it as the bigger the denominator, the smaller the angle. Okay, so anyway, that's just a side. So if we're going from 0 to pi 8 of sine 2x dx, then what we do is, okay, the derivative of what gives you sine? The derivative of what is sine? So if you go back to what I did earlier, the derivative of cosine is negative sine. And so we're going to need a negative sign with ours. So what we do is put a negative. We're going to be evaluating this from 0 to pi 8. And if we want guess and check on this, if it's 2, then let's try with a half. Negative a half cosine 2x. Okay, so let's do the derivative of this and see what we get. So the derivative of negative a half cosine 2x would be a half. Okay, the derivative of cosine is negative sine, so your negatives cancel. And then we have sine 2x. Then we would have to multiply by the number in front of this, and so that's 2. 2 times a half is 1, and so we get sine of 2x. And that's what we actually want. So guess and check. Start with something and see if you end up with what you want. That'd be my recommendation. So if we have our sine of 2x, then we're going to need a negative 1/2 cosine 2x. Okay, so now we just need to evaluate that. So we have negative 1/2 cosine 2 times pi 8 minus parentheses negative 1/2 cosine 2 times 0. Okay, well this is negative 1/2 cosine pi fourths, which is something we can actually do. That is square root of 2 over 2. And let's see. So pi fourths is here. You have square root of 2 over 2 for both x and y. That's how I knew this part was square root of 2 over 2. And so when you multiply that, you get negative square root of 2 over 4. Now, for this other part, we have cosine of 0. Cosine of 0 is 1. Because it's the x value. And so this part changes to plus 1/2 times 1. So basically plus 1/2. So what we need to do is add these two and get a common denominator. So the common denominator would be 4. This side we left alone. This side we had to turn into 2/4, since 2/4 is the same as 1/2. And so this is 2 minus square root of 2 over 4. And that's our answer. That's going to be a good stopping point for this video.